Okay, so naana ta sa week na asa na may week. This is November 29 to December 5. Okay, so nasulod pa ta sa week kay December 2 man ta. Okay, so good afternoon. Welcome to our class, no? Virtual class. So our coverage for today is actuators and control, particularly control valve. Okay, so I'll be sharing my PowerPoint. Stop presenting. Then present my window na siguro no para window. Window. Yara. Hide. Okay, mga ba na ako nakita sa kwan? Wala lagi nag-presenting gilaw stop presenting sa amin. Present again. A window dapat imo sa dang kuan kalimot na ko. Kuan siya. Okay. So naka-slideshow na ba?
Yes, sir.
Na presentation. Okay, so actuators and control. Okay, so control valves particularly. Okay. So definition. Kasi kaila what is a control valve? Okay. So something control valve. A control valve is a valve used to control fluid flow by varying the size of the flow passage as directed by a signal from a controller. So, kita may familiar na itong flow control valve. So, pare-pareha ng flow control valve or in general na control valve. But this is different from directional valves. Okay? So, dili ni siya pareha sa directional valve but pareha sa flow control valve. Kadumdum pa mo sa yung pneumatics. So, bitong hinahinayon ninyo ang pag-extend sa cylinder. Kadumdum pa mo to. Those are example of flow control valves. But this time, we're talking about bigger na, dagko. No, dagko siya. Okay, dili na pareha kagamay atong flow control valve. Okay, so this enables the direct control of flow rate and the consequential control of process quantities such as pressure, temperature, liquid level, and so on and so forth. Okay, in automatic control technology, a control valve is referred to as final control element. Okay, so in operation, okay, so paano siya? The opening or closing of automatic control valves is usually done by electrical, hydraulic, or pneumatic, no? Ng mga actuators. So, example, makita ninyo na magliyok-liyok sa kita ninyo? Kita nyo, guys?
Yes po.
Yes, sir.
Okay, so mara ginana, no? Mara tawag opening and closing, no? Okay. Okay. So, an example of an electromagnetic na operated na control valve or this is under electrical, no? So, mana siya. So, sa inyo nakita ba ay gitawag na electromagnet diri sa right side kanang na DC supply. Okay? Or electromagnetic na control valve is also known as solenoid control valve. Okay? So, nasa mura siya relay, no? Mura siya relay na nasa spring return. Except that it is connected to the plug, no? Matong plug na mag-open o close sa iyang flow. Or kung ginagmay na version, no? Mano yung mga ginagmay na type, no? These are solenoid valves, no? There are different parts. Commonly, ang kaning iyang spring, no? Nasa spring, no? Course, the coil, or the electromagnet, and so on and so forth. So in terms of operation, another example is electric motor operator or under electrical. So inana ba eh? So kakita mo giyon sa pag-connect sa motor, okay? So pwede inana no, dual na siya. Pwede siya manual, pwede pud sa electrical kay naa man siya couple man siya sa kanang iyahang kuan no, na handle no, pwede nimo matuyok no. Then usually kuan no, tawag ani, napay mga gagmay ni na version and this type of kuan electric motor operated kuan siya ball valve ball. Kailangan mag ball valve no. Pag ball valve lingin no, lingin na ang iyang sulod patuyokon ni siya. Pwede na siya manual na ball valve but this time gibutangan siya og actuator. Gibutangan siya og actuator diri sa kanang ibabaw ani the electric motor na actuator. So pwede na din siya matistuyo. Okay? Then another example is hydraulic. Wala pa ko kakitaan eh. Kaniya, wala pa ko kakita. So, dili kini siya gagamiton. If ever na naay gagamit ani, I don't know kung asa no. But usually, wala kay ko kakitaan ng kuan. Meaning hydraulic operated na control valve. So, inani siya pag proportional siya or modulation position. Kana bitang pwede kuan 10%, 5%, 30%, and so on, so on, until 100%. So, pero kung duwa lang ka kuan, logic, open na or close, so inani ang kita nimo. Okay? Okay, so ang pinaka-common is ang pneumatic operated. Okay, so nakita niyo guys, no, naa siya ay pneumatic air supply na constant, no. Before siya i-connect sa kaning iyang kuan, smart valve positioner, or kaniyang kung dili siya smart positioner lang no, naagi na siya FRL no, filter regulator lubricator or pwede ra pod regulator lang no. Pero as much as possible pwede duha no, filter regulator, pwede na walay lubricator particularly if operated under kuan food food manufacturing, wala na nay kasagaran lubricator kay o mix ang oil product no, mo nang pwede ra dili kompleto ang FRL. As long na na-filter, may regulator po. Okay, nakita ninyo ang pag-opening niya, no? Actually, this is an example of a proportional control valve. No? Pwede pa siya 0%, so on and so forth. Kita ni mo na musaka siya. As well as a current, no? So, kita ni mo ang current na 0, 4, 8 milliamps, 12 milliamps. Okay? So, mao ni ang isa sa pinaka-common diri sa Mindanao. This is Asbel or Yamataki. No? Ang ganing sa kuan, ganing sa left side, mao ni ang gitawag na smart positioner valve. Nga na siya smart valve positioner kay if ever na ibalhin nimo siya regardless of the size of the kuan of the proportional control valve, mo adapt ra siya. That's why it's ngalan sa smart valve positioner. Pero kung dili siya smart, dili siya pwede balin-balin. Okay? So fix lang siya sa specific na size. Okay? Okay, another pneumatic na operation, ganirang close open. Okay, close open lang siya. Okay. Then there's also known as air to open or air to close. So normally mabantayan nimo pag air to close ang kaning iyang pneumatic na piping is nasa ibabaw. No? Air to close gina siya. Pag nasa ubos under air to open. So pasabot ang spring kung tanawan nimo ning spring dire. So kani by the way ganing nasa GIF na to example ani is air to close. So pasabot normally open na siya because kung walay air ang spring motulod man pataas, no, pataas. So mo-open siya. Okay? And there's also known as fail to open or fail to close. Okay? So we go now to control action. So there are two possible no control actions ano gitawag na air to open or kung gusto ka na hydraulic siya or general na fluid to open or current no, or electricity. Para simple na lang air to open. So what is meant by air to open is the flow restriction decreases with increased control signal value. Okay? Dayon, nga pa gitawag na air to close. No? The flow restriction increases with the increased control signal value. Okay? And there are also two possible safety modes or failure to safety modes. No, gitawag na fail to close o fail to open. Okay? Kasi pasabutan ng fail to open, no? Pareha na, no? Ganiyan, no? Pag mingon kag fail to open, no? Pasabot kung mawala ang hangin, no? Pareha ni diri sa right side, pag mawala ang hangin, open sa close. Pag mawala ang compressed air, so open sa. So mo ni pasabot na failure. There will be failure sa hangin diri na mao nag-control the control media which is the pneumatic air or compressed air mag-fail. So, kani siya, fail to open because ang spring niya, iput man niya pasaka ang diaphragm. So, kung walay hangin diya, fail to open. So, kaning fail to open na control valve is depende na kung asa ni mo i-apply. Kung steam na siya ang application, init ka ng steam, no, dili siya applicable ang fail to open. Dapat ang applicable siya is fail to close. Pasabot, kung walay compressed air for a pneumatic na control valve, dapat ang spring nasa ibabaw, siradaan niya. Kaya nga naman, otherwise, ma-expose, no? Ma-expose ang gatong mugawas, no? Mugawas. There will be flow of steam. Init kayo. If there was a failure, so let us say, doon na po yung mga mang-open lang di agkalit sa inyong system due to power losses, power outage, no? Or brownout. So, manang ang practical is fail to close. No, ano yung pinaka-practical. Para wala gyud ma-expose sa kanang hot na mga kuan element ng mga paso. Okay, na may pangutana? Wala. So we go now to the types of control valve based on functionality. Okay, so mo na giniingon na proportional control valve. Okay? Okay, proportional controls the flow parameters proportional, no? To an input signal received from the central control system. It can be, based on my experience, duwa ra ka klase na signal lang so far ang nakita, pneumatic or electrical, no? Kurente or pneumatic. Okay? Then another type is the shut off or on and off lang na valve. So, pag dili kay critical ang ang control system, no, or process control system sa certain na na plant or equipment, ang preferred nila is on-off valve. Kaya nga naman, mas barato siya. Okay? I-on lang nimo, i-off, i-on, off. Ang pinaka-typical ni, kanang bitong heater, wala ka heating element, ang pinaka-common na ganang on-off lang na style. Madala ra, makaya ra. Pero pag dinagpo na na system, preferred ang kaning gitawag na proportional control valve. So, mao ni sa example ganiya, no? Na proportion ang iyang pag-increase or pag-open o pag-close. So, this is a current controlled man, no? Though it's a pneumatic control valve, proportional pneumatic control valve, pero ang the control sa iyang kaniyang positioner or kaniyang mismong plug or valve, no, is ang current, no, coming from the controller itself. By the way, ang kaning sa left side mo ni ang smart valve positioner. Okay? Dayon, these are some of the parts, no? Of course, no, na diaphragm dere, no. So this type of valve is ang position niya kaning spring nimo is normally open or kuan siya fail to open. Kinaaman diri ang spring i-push niya ang valve dito. Pero kung baliktad, no, baliktad ang diaphragm nasa ubos, no, kuan siya, fail to close. Okay? So, okay, mao ni ang katong kuan plug no sa imong valves. Then kani valve seat kung asa siya maglingkod, ang spelling sa seat kani yung seat no ng bangko. Wala lang na kuan diri no valve seat. Then in the kuan preventive maintenance ani usually in my experience no naka-pull out na mag 10-year-old na pneumatic control valve. So usually nanay ang kuan lifespan no 10 years provided na ma-maintain mo siya. Okay? So siguro ang ganing iyahang mga repair kit na naman sa mga repair kit na ginagmay na pwede nimo siya pang-ilisan no. Hindi. I don't know kung spring seat ba to ang isa sa kong gilisan. Then ang isa ko gina-check is ang kanang diaphragm kung nabay buslot, no? Nabay sa buslot. Okay? Dayon we proceed. Okay, so these are the kaning also known as kani siya diaphragm actuator proportional valve. Okay, so but usually most of the pneumatic control valve are diaphragm actuated. So these are the three important parts, no? Diaphragm, the spring, and the steam. Okay, as well as the kuan, no? The plug sa imong kuan, plug sa imong kanang mo kuan ba mo taklob, no? Mo close man ang iyang plug. Dayon ang yang seat kani lingkuran no literal gid mo lingkod sa dia. Then of course the inlet and the outlet. So take note dili siya pwede mabali na gini direction. Di kayo ninyo manotice no. Actually na siya direction diri yo. Kuha na siya low resolution na. Di siya pwede bali-bali ha. Okay, diri di gyapon manotice. So dili na siya pwede mabali-bali guys. Tanawon yung arrow, naman na siya arrow. So one of the preventive maintenance ani pag moabot na siya og mga bata na to 7 to 10 years siguro, there's a probability na ang kaning iyang pag-close sa iyang plug dili na gid siya 100% ma-close. So one of the kuan technique is kanang kuan ni siya. Nakalimot ko ato sa kuan sa sa term pero nato siya powder na ang kaning mong mismong valve tip no ginatuyok-tuyok nimo siya diri sa imong so bali ang plug ug ang seat ginatuyok-tuyok na naa siya frictional powder no diri para ang point dito is para kung doon naman ganito yung mga gap no gap metal man ni siya no metal man ni siya pag doon ay mga buslot-buslot or nangataya-taya na at least mahilis siya na mo fit dito yung kuan valve seat no isa na sa mga pinaka karaan na kuan no ay kanang mga old na mga valve old na mga pneumatic control valve as one of the maintenance na kuan man no kadumdum mo sa tong the last time na equipment katubi tong bumba-bumbahan sa na pump hydraulic pump na ibutang diri ang kuan no nasiri kay flange diri na connector o sa na connector para i-push nimo ang water diri no to a certain pressure dapat normally if close man ni ay kuan man mao man common sa steam na application normally close or fail to close or spring close. So dapat pag ma-reach na mo certain na pressure na siya range po dapat walay mugawas diri tubig. So pag maabot ka na moment na siya mugawas that's the time na kinanglan nimo na siya ikuan i-grind no mag-grinding ka diri na ay grinding powder kalimot na ko kalimot ko research pero most likely that's the main idea na kay grinding powder diri i-match nimo itutuyok nimo yung plug sa imong valve seat para kung ano kanang ma-perfect na yung pag-fit sa valve so na as well as the different na mga repair kit na mga gasket na naana siya for every valve or control valve you could also request for repair kit. No? Kanang mga repair kits man ay usually kadaot, no. Nanay mga additional na mga mga gasket, mga napuli-pulihan. Including the diaphragm, no. Pag major na mga repair kit, appeal na ang diaphragm. Pwede pa din mapulihan ang diaphragm. So there are also direct and reverse acting actuators. So ano itong giingon na naigitawag na air to close, air to open, normally close, may nana, no? So ano siya. So makita nimo dire sa arrow, no? Pag ang air gani padong didto, pasabot, kung wala yung air, musaka na siya. Pag musaka na siya, open yun. No? Open, normally open. Bali, ang air may magpa-close. Pag ang air nasa taas, no? Kung wala yung air, na may string dere, tulod na niya, then that is one. Kaon sa man eh. Ganun to, ang klay na sa ning duwa. Baliktad ang posisyon niya sa sulod. Okay, baliktad. Okay, baliktad din na siya. Usually, ang naandan na nako kaning nasa ibabaw ang mismong plug. Kani kay ang plug na din sa ilalom. Okay, so wala po ko experience ang plug na sa ilalom. Kanirang duwa. So far, ang pinaka-common, kanirang 1 o 3. Okay, but tingala kung ano na upat. Ang ilaning plug na sa ubos. Okay, so ubos na siya. Wala po ko kita na. Kanira kasagaran duwa ko nakita. Okay. So, gitawag siya reverse acting. Ikuan man, sirado man siya daan. No? So, kuan siya, reverse acting. Kani, direct acting kay open sa daan. So, mara na siya bantayan. As well as this one. Para pa sa akong i-explain din niya. Okay, so we go now to on and off na control valve, no? Such as the solenoid valve, no? Inaani na i-close, open. Okay. For kuan na nila, non-critical na process control system. Pag critical siya, no? Or taas ang accuracy required, katog yung proportional yung kinanglan rather than the on and off control valve. Okay. Nakita na ko ning ball valve na type na motor operated na control valve is kuan. Kaning mga kuan na dryer, oven type na dryer. Pag oven type na dryer na i-close siya, i-close yun, usually nani mga kuan siya. Kay barato man. Barato siya. So katong dili ka afford og pneumatic system, kay magpalit man mga compressor sana. They opted to use motor controlled operated na control valves. On and off. I don't know, wala pa ko kakita og ganang proportional na motor, no? Control valve. Instead, ang kasagaran pneumatic. No? If ever na mas barato gyapon siya as compared to pneumatic control valve. Kay mas durable man ang pneumatic. Okay, so we're gonna type the control valve based on the movement profile of the controlling element. Okay, so pag ningon kag sliding steam, no? Katabi tong saka kanaog. Okay? So example na is the type of plug, no? Is the kuan globe valve. So globe valve usually mo nang ginagamit sa kuan proportional control valve. Na pay angle body valve, na pay angle seat. Kaning angle seat murag naka-tilt ni by 30 degrees or 45 degrees. Para na yung itsura. Then axial flow rate valve. Then katong rotary, katong example, katong motor, no? Motor operated na control valve. Rotary siya tuyok. Okay, ang uban, butterfly, no? Ang butterfly na valve is kamo na like click ani kay malangan na ta. Kamo na like click sa link itsura na nila. Nagingan lang bisag butterfly kay murag bisag butterfly. Na butterfly valve is commonly used for sanitary application as it is simple to clean. Unlike the ball valve, no? Kinanglan pa to nimo limpyuan, bula man sa sphere. No? Unlike sa kaning butterfly, kay kuha na siya, mura siya coin na i-flip nimo, no? Mura siya coin. No? Flat surface, circle na siya na i-flip. So that's why commonly used for sanitary application. Pasabot ang ganang media niya isang katong food product, no? It could be a milk, no? A milk na mo agi sa kana na bulb. Ana. So naman na yung mga residue, mas maayo ang butterfly bulb kay dali ra limpyuhan. Unlike sa kaning ball bulb, this is sa limpyuhan. And mas paspas pa ning butterfly bulb as compared to ball bulb. Okay? And so on and so forth. Okay, there is also, kung naanad mo sa inyo ang one, pneumatic or hydraulics, diba na may gitawag na two-way valve or two-way valve, no? So, pero pag mo, istorya na kag-control valve, pwede ka mapun nga mo three-two-way control valve, but preferably, para dili ma-mix, pwede ra nga mo na three-way valve, or three-way control valve, or two-way control valve. Kuha ni siya, usually for pneumatic ni siya kasagaran, doon na apoy kuhan, electric, motor operated. Pero para paspas ang operation, no, it's preferred ng pneumatic. And this is alpha label, no, kung mabasa na ninyo, yan ang logo. And it's used for sanitary na application. No, kinanglan og three-way valve kung there will be ang kanang kuha na siya, kanang gina-recycle niya ang kuha, no. Bitan, wala pa niya na-reach ang katong certain na temperature sa imong product. Kami, na kay milk, no? Kay milk na product, i-pasteurize nimo to, buta na to, ito may kasagaran, 90, no? Buta na to, 70 to 90 degrees Celsius. Wala pa gini na-achieve ang certain na temperature, buta na to 90. So, buhato niya na tuyok niya, no? Patuyok niya sa system. Patuyok-tuyokon. So, magamit ka ng three-way valve. Gamit ka na. Then, in tandem with two-way valve, pwede magamit. Okay, so we go now to application. Now, one of the application in control valves is kaning kuan, no, in food manufacturing. Kailan mo ani? This is a desiccated coconut dryer, no. Kani usually 3 to 4 stages, no. So this is from India. So here in the Philippines, India na technology. Okay, barato man. Okay? What type of dryer? So this is a band dryer. Okay, mura siya rubber band. Or ang belt niya, matong band. Or belt dryer. Or continuous apron conveyor dryer. So, mana siya. Kinaasa na yung ngalan. Okay ra. Then sometimes, ginatawag po siya as tunnel dryer. Tunnel kay. Mura ba siya tunnel na yung sudlan. Okay, so manotice ninyo na ang kuan na source sa heat, no? Source sa heat is actually the steam coil. So, mao na ang mga pula diya. So, assuming we have the 3 stages, no? Mga steam coil ng mga pula. No? Steam coil. Diya mo sulod ang imong steam. No? Then, of course, na kay mga blowers, circulating blowers. Okay? Then, exhaust blowers. Okay? Kay para kung ano mo, no? Heat transfer by convection. So, by hangin. So, nana na siya. Then, mangutana mo, taraman dapit ang mga circulating blowers. So, nana siya. No? Pangbutang sa ibabaw. So, nga na baliktad man na. Kaya manotice nyo, nga na baliktad man. So, pagtulod na there is a product, because this is a desiccated coconut, bugat pa na siya. So, dapat ang direction sa hangin, no, paubos. Paubos siya. Paubos. Okay? Then, pag dire na siya, pwede na pataas. Gaan-gaan naman siya. So, pwede na pataas. Okay? Anyway, bilir kayo na siya kuhan. Okay? Magbutang og BFD. So, dili na siya technically appropriate, mas appropriate ang Danfoss. But since nabaratuhan naman mga ni, amo na lang ipanindigan si Allen Bradley. Okay ra ba si Allen Bradley? But there is a problem with the no? Itong iyahang sige to, coil, no? Coil na requirement, wala siya. So if there will be power outages, dali rin siya madaot. Kay kuan masunog dayon due to fluctuation. Okay, so kanang red na line, this is the steam line. So steam na siya. Steam dryer man eh. Dayon ang kanang sa ubos, mao na ang condensate, no? Mao na ang katong nanay tubig, no? Steam with condensated na siya. So nanay tubig. Okay, so the blue. So ang assumption na lang, murag bugnaw-bugnaw sa relatively bugnaw. Okay, so versus steam. Okay. So naa kay kaning bulb na arrangement diri. Then kay kuan temperature controller, then kay kaning mo ang kuan sensor nimo no, temperature sensor. It'd be an RTD. Okay. Okay, so katong circular rectangular pula man yung component. So kung pangutana nimo sa may relasyon, may relasyon. Mao ni ato ang no, proportional control valve or pneumatic control valve nato na proportional siya. Kung sa nilang uban sir. Okay, so those are kaning mga manual valves, no? Could be a gate valve or a globe valve. Okay. Then siya kaning kuan kaning filter, no? Para if ever na yung mga hugaw, diri ra mga sangit. Then sa anong apa magina sa taas? Kitay makatagan, ngano napa magina sa taas? Na sometimes magguba maguni siya good, no, magguba. In case na magguba siya, so balik ka sa mano-mano. So take note, this is automatic and this is mano-mano, manual. So ang buhaton na nila, hinahinayon na nila open diri na valve, and kani anam-anam og close para ang steam niya ma-bypass diri na sa taas mga. Dayon, of course, na monitoring sa kuan sa pressure. There will be pressure difference between the input and the output. Naana na siya hugaw di sa sulod na block. The assumption there is they must be equal. Kung na magi losses, gamay lang. Okay? Gamay lang. Okay? A valve man. Gina-control man niya ang opening and closing. But kung ma-normalize na ang kuan, ang pressure, mag-equal gina sila. Okay, so these two valves are bypass na valves, no? Para ma-close nimo kay init di kayo before nimo i-pull out ang imong kuan. By the way, ang gani diri mga ball valve na sila, no? Kay kung di pa na nimo buta ball valve, di pa na nimo matest kung guba ba ang inyong pressure gauge. So, take note, kay uyog-uyog man ni siya. So mas kuan no katong liquid filled na kuan na type, dili katong dry na type kay kung steam ni na area na di na nimo mabasa. Okay? Then of course, the smart valve positioner, diya naka-connect ang 4 to 20 niya padong sa imo temperature controller. Of course, ang imo pong PT100 or the RTD na kuan, connect ba na sa imo ang temperature controller. Dayon ang output din ani steam ram ni siya. Padong next sulod sa steam coil. Okay na may pangutana? Wala. Mura na siya ginani, no? So, ang next na po na ginatanaw na to is ang kaning sa ubos na portion, no? So, wala na control valve dari. Kuha na siya return to boiler. No? Padong na siya boiler, guys. Steam na. But, magbutang niya pag steam trap, no? Steam trap, pag ang kaning kuan, kaning mga filter. Okay, kung manotice ninyo, sir, ganong dira man na dili sa tunga. Mas pabor na diya kay diya man nagsulod, no? Just like dire, diya man nagsulod. If ever na naay moisture dire or condensate, mubalik ra hulog. Kaya ang condensate man god maka-cause na siya og ganang vibration, no? Mura na siya lightning na reaction, no? Ang hot ug cold magtagbo gani na sa kuan, sa ulap or sa atmosphere, mag-lightning na siya. So, the same principle, mag-hammering na siya kung dagay tubig diri sa sulod sa imong babaw, no? So, para dili siya mopundo sa tunga-tunga, mas better diri na lang. Para hulog siya dirito. Okay? Para hulog siya. So, mga na ilang best practices. And by the way, this is a kuan, a check valve para dili lang na siya mobali ang direction. Hindi siya mobali. So, inani ang complete na setup. So, the red the red na line indicates the hot media, which is the steam. Pasulod sa imong steam coil para mao ni imong heat source. Dahil ang kadto yung course na maginay after heat transfer na maginay kuan losses no, so condensate na siya na imong steam na nay tubig-tubig. So, same gyapon, but instead of control valve kay dili na mag-control, butangan ni mag steam trap para ang gatong mga tubig-tubig diri mo gawas. Dapat ang gina-return na gid as much as possible is steam. Wala apel condensate. Okay, so mura ginana ba ang ang wala lang drawing niya. So manotice niyo diri na siya check valve para dili mo baliktad ang ang flow steam. Basin pagawas, dapat it will remain pagawas. Dili siya mo balik pasulod. So that's why importante na makasabot mo sa inyong check valve or one-way valve. Okay, so inana siya ka complicated ang tunnel type na steam dryer or desiccated coconut dryer. Okay, so ito na may oras. You go now to video na ba ita, siya. How to calibrate and to maintain nawala kong gi-share. Ato sa dito i-click. Saan dito? Click sa ano. Okay. I-share na ko ang tab. Share the
Although you have repacked and reassembled the control valve, you must give it a thorough operational check before you commission it. To check it, you will need a 0 to 30-pound test gauge and a bleed type reducing regulator. The regulator will provide an input signal. Here is what your test hookup will look like. Consult the valve specification sheet to obtain the input pressure. 3 to 15 psi is the standard input, but some control valves have a bench set. Bench set is used primarily for single-seated valves. For instance, the flow against this plug tends to force it upward, so the actuator spring is designed to take the plug force into consideration. But during a bench calibration, there is no flow to oppose the actuator. Hence the name bench set. To check the stroke of the valve, you might have to apply 3 to 12 psi rather than 3 to 15 psi. We will check this valve first. It is a 3 to 15 psi air to open valve. Apply 3 psi. Make sure the plug is just touching the seat by loosening and turning the plug stem. Apply greater than 3 psi. Then screw the plug stem into the actuator stem 2 more revolutions. The extra 2 turns will ensure that the valve seats solidly. Lock the stem lock nuts. Apply 15 psi. Make sure the valve has full travel. Adjust the travel indicator if it doesn't agree with the indicator disc. Stroke the valve several times, stopping at some intermediate value, 9 psi for example. The valve should always indicate 50% travel with 9 psi input. If the valve doesn't repeat, it has hysteresis. This can be caused by tight packing. The air close valve is checked in the same manner. However, the valve will seat at 15 psi rather than 3 psi. Slowly apply air pressure to the valve. Observe the valve stem travel. Note the input pressure needed to seat the valve. Make adjustments if necessary. You should make the valve barely seat at 15 psi. Then lower the pressure. And screw the plug stem out 2 revolutions. Then lock the lock nuts. Check the valve for hysteresis. Then commission it. Now, work exercise 3 in your workbook. Suppose an operator tells you that a control valve is sticking, stuck, or controlling poorly. This problem is not obvious. You will have to troubleshoot the system. First, ascertain that the instrument signal is reaching the control valve. This controller has 100% output. You would expect the signal at the control valve to be 15 psi. And you would further expect the valve travel indicator to show 100% valve travel. If the controlling instrument output signal, the signal at the valve, and the valve position do not correspond, there is a malfunction. Ask the operator to bypass the valve. Install a 0 to 30 psi test gauge at the control valve. Verify that the controller output and valve signal agree. Let's assume the controller output is 100%, but we are receiving only 12 psi at the valve. Inspect the signal tubing. Look for breaks, leaks, or loose connections. Use Snoop or soapy water to locate leaks. Suppose you didn't find a tubing leak. Remove the tubing from the actuator. Dead end the tubing into the test gauge. The signal pressure built up to 15 pounds. This tells you that the leak is in the actuator, not the tubing. Study the cutaway. Where could a leak occur? A ruptured diaphragm would certainly leak. And loose diaphragm case nuts would cause a leak. Use Snoop to find the leak. This leak can be repaired by tightening the case nuts. If air is escaping around the adjusting screw, the diaphragm is probably ruptured and needs replacement. Remove the tubing, then loosen the actuator spring tension by unscrewing the actuator adjusting screw. Failure to release the spring tension can result in a serious accident. Remove the upper diaphragm case, the actuator stem screw, and the diaphragm. Inspect the diaphragm for splits, holes, cracks, or tears. Replace the diaphragm if necessary and reassemble the actuator. Connect the signal input tubing. Apply 3 psi input. Turn the adjusting screw into the yoke until the actuator starts moving at 3 psi. Check the stroke by applying 15 psi. Verify that there are no air leaks. Then commission the valve. Never exceed the maximum signal pressure by 5 psi. If excessive pressure is applied to the diaphragm, greater than 40 psi, the diaphragm case may burst. A piston-operated valve may also leak signal air if the input bellows is ruptured. If the bellows is suspect, leak check it. Remove the bellows by taking off the air supply and instrument signal tubing. Then, remove the 4 screws that hold the bellows in place. and install a new bellows. Now, work exercise 4 in your workbook. Many times,
There's a pattern to genius. There's a method behind the magic. I always tell people my inspiration was my desperation, and I don't do this to impress.
the proper signal is present at the actuator, but it still will not operate properly. A spring-opposed diaphragm-type actuator will rarely have anything out of order other than the diaphragm. But the piston-operated type actuator, since it is more complex, may have other problems. Assume this piston operator is receiving the proper input but won't move. First, check the obvious. Make sure you have an air supply between 35 and 100 pounds and a valid input signal. Now, determine if the problem is in the actuator or the valve. Observe the top and bottom cylinder gauges while you vary the input signal. For a direct acting actuator like this one, the top cylinder pressure should be greater than the bottom cylinder pressure when you increase the input signal. The bottom cylinder pressure should be greater than the top cylinder pressure when you decrease the signal. When the valve reaches the point in its travel that corresponds to the input signal, the pressures will be approximately equal. Now, suppose we increase the instrument signal pressure, but the top cylinder pressure remains at 0. We can definitely conclude that the actuator is in bad order. We have isolated the problem to the actuator, and we can further isolate the problem to the positioner, since it supplies the cylinder pressures. Furthermore, we can isolate the problem to this relay, since it is the one that loads the top cylinder. Notice that the flapper is covering the nozzle. This definitely indicates that the relay is at fault. Examine this simplified relay schematic. What would cause 0 relay output even though the flapper covers the nozzle? A plugged restriction orifice is a likely cause. A plugged restriction will prevent any back pressure at the nozzle. This is an actual cutaway of the relay. R is the restriction orifice. Also notice the built-in orifice cleanout plunger. By depressing the plunger, you can run the wire through the orifice and remove any obstruction. Now, observe the top cylinder gauge. It indicates that the relay is now functioning properly. Let's review the technique we used to solve the problem. First, what was the problem or symptom? The problem was the valve won't move. The malfunction could be in the valve or the actuator. By observing the cylinder pressure gauges while we varied the input, we determined that the problem was in the actuator. We noticed that the flapper was covering the relay, but the relay had no output. And finally, we solved the problem. Cleaning the orifice was the obvious thing to do first. We could have found and corrected the problem by disassembling the relay. But remember, look for the obvious first. Now, work exercise 5 in your workbook.
You see, we edit a lot of videos every day, so we don't get much time to answer emails or write long proposals for clients until we
Okay, so we proceed to our next video. Okay, ito next video. Share this instead. Then play.
We would almost always like to have control over different parameters of the process, like temperature, pressure, level, and so on. To achieve this, obviously we need a controller, like Programmable Logic Controller, or PLC for short. We also need some sensors and transmitters to send data over to PLC. Finally, we need a piece of equipment to carry out the PLC's commands, which usually called as final control element. A final control element can be a pump, a heater, a control valve, and so on. If you would like to figure out how control valves exactly work via an interesting practical example, stay with us to the end of this video. And if you like this style of video, subscribe and click the bell to receive notifications of new videos by Upmation. Very often by control valves, we mean the type of valves that are used not only to fully start and fully stop the flow, but also to control or adjust, or in other words, throttle the flow of the liquid. By throttling the flow, we achieve our final purpose, that is, for example, controlling the temperature of a furnace or the level of a liquid inside a tank. You may say how it is possible. Don't worry, we are going to talk about it in detail. Well, this is a globe valve, one of the most common types of control valves. Let's take a quick look at its different parts. This is the body of the valve that the fluid will pass through it. And this is the bonnet that is connected to the body and covers its inner parts. We call this part plug. The plug will control, stop, or start the flow by exposing the liquid flowing inside the pipe. This part here is the actuator that transfers the mechanical power to the plug using the stem. The actuator will receive the commands from the positioner. The main role of the positioner is to be an interface between the PLC and the actuator to precisely adjust the plug for being open or closed. There are a variety of actuator and positioner types, and we are going to check them all at the end of this video. So let's start with an example to understand the operation of the positioner and its relation to the PLC and actuator. In this example, we aim to control the temperature of a liquid within a tank by regulating the flow of an additive. This additive will generate heat by having a chemical reaction with the liquid already inside the tank. Say the PLC decides to send a 50% open command to the control valve. This command is based on two items. First, the PLC logic, and second, the feedback it has received by the temperature sensor installed on the tank. This command signal often is in the form of a 4 to 20 mA DC electrical current and is sent from the PLC. The device that receives this signal on the field is the positioner of the control valve. As we are using a specific type of pneumatic actuator in this example, which needs compressed air to become activated, therefore, we chose an electro-pneumatic positioner. Don't worry about the names at the moment. In this case, the positioner plays the role of a translator and converts the PLC language to the actuator language. It means that the positioner will convert the 4 to 20 mA signal to an air pressure signal. But how it happens? Well, inside of this positioner, we have a converter unit, which is called I2P transducer. In fact, this transducer converts the 4 mA DC current to a 3 psi air pressure, and the 20 mA DC current to a 15 psi air pressure. And of course, they are proportional in the middle range. We call 3 to 15 psi air pressure as the pneumatic signal. So with a simple calculation, We understand that in order for the PLC to open the valve for 50% of its full range, it should send a 12 mA signal to the positioner. Then the positioner will convert it to a 9 psi signal accordingly and will send it directly to the actuator. But wait, it sounds like the 9 psi pressure is not enough to move the actuator. Therefore, we need another input to the positioner as the air supply. The air supply input will provide us with a clean, filtered, regulated air with sufficient pressure thanks to this filter regulator device. After all, using the air supply input and a built-in pressure amplifier, the positioner will be able to convert the 9 psi pressure signal to sufficient air pressure for moving the actuator to the right amount. Now we see that the actuator is able to overcome its spring force, and so far so good. But same as the PLC that requires feedback by the sensor to decide about the command it is going to send, the positioner also needs to receive feedback to precisely position the valve stem and open the valve to 50%. This feedback is sent by the control valve to the positioner using a mechanical mechanism. In this way, the positioner will decide how much pressure the actuator needs to move the valve stem. In general, positioners come into three different categories. First, the electro-pneumatic positioners, or I2P positioners, that we already discussed in the example. Second, the pneumatic positioners, in which their control signal is a pneumatic signal and they do not need any I2P transducer modules integrated. The last is digital positioner or digital valve controller. In addition to an I2P transducer, these positioners take advantage of a microprocessor to fill in the place of the mechanical position feedback. The input signal or setpoint from the PLC will directly send to the microprocessor. The valve position feedback, which is measured electronically, will also enter the microprocessor. Comparing these two electronic signals, the microprocessor is able to adjust the valve position quite accurately in comparison with the other types of positioners. Using digital positioners, we are able to communicate with the valve by different types of protocols, such as HART or field bus protocols like Profibus. By such digital communications, we can calibrate control valves way more easily using handheld communicators without tackling time-consuming and sometimes difficult mechanical adjustments. Besides, we can send some feedbacks from the control valve to the PLC or DCS via these communication protocols. The last point is that the standalone I2P transducers can control the valve independently in case that the accuracy is of less importance, meaning that they are not integrated into any kind of positioners and therefore there is no feedback in this case. Now that we've got introduced to the positioners, let's get into the actuators and their different types. Generally, we can classify the actuators into four different categories: pneumatic, hydraulic, electric, and manual. The pneumatic actuators are the most used kinds of actuators due to their simple design, fairly low price, and of course being intrinsically safe. Electric actuators have an electric motor inside. In the first place, they have been designed for on-off applications, but nowadays, some of them are upgraded for continuous control applications. The primary application of them is in the locations that we don't access the compressed air. In this video, we'll learn how a spring and diaphragm actuator, along with an electro-pneumatic positioner, adjusts the valve in order for the valve to control the flow of the liquid according to the PLC's commands. Well, it's time to ask us your questions or tell us about your experiences dealing with the control valves in the comments. Again, if you like these kinds of videos, please subscribe and tell us which subjects you are most interested in. Thanks for watching.
Okay guys, I hope na sabta ninyo dunggan po. Okay, may pangutana. Selfie sa ta. Pakita na mo diha. Pangkuhan ba pang dinaghan natin dad. By the way, since ang pneumatic control valve is or any control valve, there is a tendency na from time to time gina pull out man siya. So one of the common weekly na maintenance is ginasprayan of WD-40 ang mga bolts niya no, nuts. Para kung the time na tanggalo na nimo siya, pwede nimo siya matanggal. So mao na ang usual na kuan weekly niya na preventive maintenance no. Aside sa gina-check ang katong kuan niya, ang response niya no kung okay pa ba yung response in terms of the 3 to 15 PSI na kuan or 4 to 20 na response no 50% ba siya 100%. Okay, so gina-check po na siya no? Then of course dili kalimtan tong kuan mag-spray og WD-40 sa mga nuts niya kay if time na mag-trouble siya dili siya ma-pull out kay kung due to ka ng corrosive na environment or kuan dali raman tayon god usually no ang kanang mga nuts niya bolts na kung dili nimo weekly na mabutangan og kuan WD-40 maglison ni kagtanggalan no. Okay, so naamoy pangutana kung wala ako na ning stop recording. Stop recording. Sunod